Good afternoon. Welcome to today's lesson on 9.6. So as I said, eventually we're going to start moving the center or the vertex of our types of graphs away from 0, 0. And so that's happening right now. Before I do some examples, it helps to look at general equations for each type of graph. So if we look at a circle, this is something you should have seen back in geometry or even in Algebra 1. The equation of a circle is just that. So just notice how we add h and k. So h and k here represents our center for the circle. For the parabola, so see how like y squared equals 4px was the old way we looked at it. Now it's going to be y minus k squared equals 4p x minus h. So in this case, h and k represent the vertex. And then for ellipse and hyperbola, h and k represent the center for each one. Everything else is still the same. It's just that now, again, the center vertex won't be at 0, 0. And so h and k represents what those values will be. Not sure if you've noticed, but notice how I'm labeling each type of graph, or the category I'm using for each type of graph. I'm calling it a conic section. So here's a question I posed to all of you guys before we do our examples on the next few pages here. Why am I calling each type of graph a conic section? Well, I will do a demo to truly answer this question. During block number 2. But kind of just get you thinking about it. This right here is called a double napped cone. If it's cut in a particular way, the cross section will resemble either a circle, parabola, ellipse, or hyperbola. It's a little bit hard to show you through a video. It's better if you actually see in person, something that's more 3D. So I will do the demo again during block number 2 this week. It actually will be pretty fun. I think you guys will enjoy it. It's actually a little dangerous too, but dangerous for me, not for you guys. And you'll see what I mean by that when we do the demo on block 2 this week. So now let's do a few examples, so that way you have something to kind of follow when you do classwork the next day. So in this case, we're asked to graph x minus 2 squared plus y plus 3 squared equals 9. Identify any important characteristics of your graph. The first question you need to ask yourself, what type of graph? Or what type of conic section will this be? Hopefully you could recognize this as a circle. That's because x squared or x and y are both squared. And positive. And same coefficients. So the second step will be identify the important characteristics. And the third step, just graph it. So if I think about it, because it's a circle, center will be at 2, -3, because remember that's h and k. H equals 2 and k equals -3 for this problem. Going all the way back up here to that general formula for a circle. And r, your radius, is going to be 3, since r squared equals 9. So for our third step, very simple. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And actually I'm going to go 6 tick marks on each side. So if I locate 2, -3, which would be right here, and raise to 3, so if I go 3 away in each direction, so notice I went 3 up, 3 right, 3 down, 3 left. There's a circle. Actually, I could do a little bit better than that. There we go. A little more accurate there. So that's it. Very simple. Number 2. So first step, I know this is hyperbola. That's because x and y both squared, but there's a minus symbol. Second step, the important characteristics. It opens vertically because y squared is positive. Opens vertically. Center will be 3, -1. A squared equals 4, and b squared equals 9. A goes with y, and b goes with x, just because they're below y squared and x squared respectively. A is going to equal 2, and b is going to equal 3. Third step, we graph it. So center's at 3, -1. So let's see here. 6, 6, 6. Should be enough tick marks. So 3, -1. Here's the center. Now A is 2 and it goes with y, so I have to go up 2 and down 2. B goes with x, so I'm going to have to go right 3 and left 3. Make your box. Draw your diagonals. And because I know it opens vertically, my graph will look like this. Okay, kind of missed with that one, but that's okay. Vertices will be, now in this case, if you look at it, it's got to be 3, 1, and 3, -3. That's because the center's at 3, and because we're going up and down for hyperbola, we need to move up 2 and down 2 units from the center. Because again, A equals 2. And A goes with Y in this case. For your foci, remember c squared equals a squared plus b squared. So that's going to equal 13. So c equals root 13. And the foci will be roughly here and here. I didn't do this totally accurately, but that's where they are going to be roughly. And because y is being impacted, not x, the x values are 3 for both foci, right? That's 3 comma something, and that's 3 comma something. Basically what we do is we say -1 plus or minus root 13. That's because this right here is C, which equals root 13, and this right here, from the center to the focus, same thing. Asymptotes, don't worry about it. That's a little too much work. If the center's not 0, 0, don't worry about it. I won't ask for it. Okay, last one, number 3. Write the equation of an ellipse with the following information. So, as we've always said, the first step, make a quick sketch, just so you can visualize the problem. So, quick sketch. So, let's see here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, change colors up for some contrast. So your foci are at 1, 2 and 7, 2. Your co-vertices are at 4, 0 and 4, 4. The vertices we don't know, obviously. But that's F and F, that's CV and CV. So roughly, it looks something like this. And the vertices will be there and there. Now, second step is to find the center and use the proper equation. The center should be easy. Just by looking at it, you can see how it's 4, 2. That's why you want to make a sketch, because it's going to be in between the co-vertices and in between the foci. So sketch helps. The proper equation will be this. Remember, we're talking about ellipse. We need a plus in the middle. And you got to go with x squared over a squared. So we got to go with this one here. Because this is horizontal. Clear the major axis horizontal here, just by again looking at the graph, and the foci be sharing the same y coordinates, so you know that the major axis is horizontal. C squared equals a squared minus b squared. So we know that C has to equal 3 according to our graph. That's B. B has to equal 2 according to our graph. Again, the graph is crucial for this. So 9 equals a squared minus 4. A squared equals 13. So now I can write my equation. X squared over 13 plus y squared over 4. Sorry. Terrible short-term memory there. And that's it. So try to keep this video under 15 minutes. Hopefully this made some sense. We'll do more practice this next time we meet. No quiz this week, because I really want to make sure we spend a lot of time just going over this. You might hear the bell. That means I have to get to my faculty meeting. So we're all done. Have a great rest of the day, and I'll see you guys later.